Hello everyone, welcome to this video. Today we will see one example that will show how we can model a lead acid battery cell using Simscape library. So basically this is a model that has been developed by MathWorks. So to open the model, we need to write a command in our MATLAB command window, that is ssc underscore lead underscore acid underscore battery. So once we write this command over command window and we click enter, so automatically this Simulink window will create it where we can see a model of an lead acid battery cell. So here ambient temperature source is present. So if we just go here, we can see the ambient temperature is 25 degrees centigrade. Then through the convection heat transfer, the heat is getting transferred to the battery cell. So if we just double click on this battery, so this is basically the lead acid battery cell. If we just double click on it, we will see battery structure. So basically the structure did not model the internal chemistry of the lead acid battery directly. The equivalent circuit empirically approximate the behavior that seen at the battery terminals. The structure, it consisted of two main parts, main branch. So basically this is the main branch voltage source and this is the main branch. Uh, so this main branch actually approximate the battery dynamic under most conditions, and a parasitic branch which accounted for the battery behavior at the end of charge. So this is the parasitic branch. Now, if we just come for the main branch, so this main branch basically approximated the internal electromotive force, or we can say as EMF or open circuit voltage of one cell. The EMF value has assumed to be constant when the battery was fully charged. The EMF varied the temperature with the temperature and state of charge, or the SOC. Then this terminal resistance, or this R0, basically approximated resistance seen at the battery terminals. This resistance was assumed constant at all temperature and varied with different state of charge value. Then this main branch resistance R1, basically it approximated resistance in the main branch of the battery. The resistance varied with depth of charge. That means how much the battery is being charged. That is a measure of battery charge adjusted for the discharge current. This resistance increased exponentially as the battery become exhausted during a discharge. Now, the main branch capacitance, or the C1, basically approximated capacitance or a time delay in the main branch. This time constant model a voltage delay when battery current is changed. Now, this main branch resistance R2, basically this approximate our main branch resistance. The resistance basically increased exponentially as the battery state of charge increased. This resistance also varied with the current flowing through the main branch. The resistance primarily affect the battery during charging, and it's become relatively insignificant for the discharge current. Now, for this parasitic branch resistance, or RP, basically approximated the parasitic loss current which occurred when the battery was being charged. Now, if we just go back, if we just so once we double click, we will open this thing. Now if we just double click on it, we can see all the parameters has been written here. So all the variables that has been written, like R20, A21, A22, I star, these all variables are stored under the MATLAB workspace. So if we go in MATLAB workspace, we can see all the value for these variables. So we can change these variables. If we want to change our battery model, we can change here, and based on that, the battery will behave. Now, So this is the ambient temperature source that is going in this battery cell. And here, if we just see, this is basically the battery thermal model, where all the thermal related thing that is affecting the battery, and due to battery charging and discharging, as the temperature is increasing, those all things are considered here. Then this is basically the load voltage that is here in two terminals of this lead acid battery cell, positive and negative terminal. So if we just go here, we can see one voltage sensor is present, and the value of the voltage we are storing in a go to block called V underscore load, so that we can see this with the help of a from block in our scope. Like this, we have used this from block V load to observe the voltage. Similarly, here, if we just go for this load current, here some current profile is written inside this file. So it's a mat file. Inside this, the current profile has been written. So based on this current profile, the battery is going to charge and discharge. We will come to this once we do the simulation. We'll come to this. Also, the current, to observe the current, we are just storing this current profile in a go-to block called I underscore load, and from a block using from block using this same name of I underscore load, we are observing the value inside a scope. Here with the negative terminal, our electrical reference has been connected, or we have grounded this basically. And as we know, so whenever we will model any Simscape model, so we must need to connect one solver configuration with it. So that's why this solver configuration block is connected. And I have not mentioned this. So this is basically the constant current source. So we are providing the current value through this current source, and it is sending over the battery, over this cell. Now, you can see the time is already set it for 72,000 seconds. So if I just run the simulation, so it will take some time to the simulation. Yeah. So once the simulation is done, so basically we can observe the parameters for all of these things inside the scope block. So basically what we are doing in this simulation, so initially the battery is discharged at a constant current of 10 amps. Then the battery is recharged at constant 10 amps back to the initial state of charge. Then the battery is again discharged and charged again. A simple thermal model is used to model a battery temperature that we have seen previously. It is assumed that cooling is primarily via convection, that is the convection heat transfer block, and the heat is primarily from the battery internal resistance. So we have seen that the internal resistance, that is basically the reason for increasing temperature during charging and discharging process. So basically this R2 is the main reason for battery internal battery heating. So basically a standard 12 volt lead acid battery we can model by connecting 6 copies of this lithium and of this lead acid battery cell. So each of this battery cell is of 2 volt. So we can connect 6 batteries in series to make a standard 12 volt lead acid battery. Now, if we just observe the behavior of these parameters, so basically the current, then the terminal voltage, the SOC or state of charge, then depth of charge, so how much it is charging and how much of the capacity it is discharging. So this is basically the depth of charge, then temperature and heat flow. If we just open the scope, so I have already opened. So if I just maximize the window, we can see here. So basically this is the load current, as primarily we have discharged it with 10 amps, then we are again charging it with 10 amps, then again we are discharging, again we are charging. So basically this is the current profile. Then this is the state of charge. As the depth of charge, if we see here, so initially the capacity or the SOC of the battery was 80%. So once we discharge it, it comes near about 0. Then again we have charge, again we have discharge, again we have charge. So similarly, 80% of the depth of charge is happened, then again charge, then again discharge, then again charge. This is the temperature profile basically. So throughout this simulation, the average temperature was 25 degrees centigrade. In some point, near about 3 into 10 to the power 4 second, at this point, the temperature has increased almost for 1.5 degrees centigrade, and it reaches near about 26.5 degrees centigrade. Then again, it reduced and again it increased here. This is the terminal voltage, as the voltage of this each lead acid cell is near about 2 volt. So we can see, so previously the voltage was near about 2.15 volt. When we have discharge, it reduced. Then again during charge it increased and again it reduced. Similarly, like the charging and discharging magnet. This is the heat flow. So basically the unit is in watt. So as the temperature is rising, that means the heat flow is happening. That's why here the maximum heat flow has happened. Then also here again heat flow has happened. We can see here. So basically like this, we can model and simulate a lead acid battery that is already available. So this model is basically constructed using Simscape example library called lead acid battery underscore library. So if we want to see that, what we can do, we can click on this open custom library. So inside this library, all the blocks that we have used to model this lead acid battery is present. So this library comes with a built-in blocks, and we can use this that are readily available. However, it is recommended that we have to copy the source file to a new directory, for which we have to write permission and add the directory to our MATLAB path. So with this help, with the help of this block, this model, we can customize the model with the different parameter. Also, we can connect multiple cells, lead acid cells, in series or in parallel based on our requirement, and we can observe the characteristics or the behavior of the lead acid battery for different charging and discharging profile. So whatever parameter we want to change, we can change here. So this is the current profile. We can change the current profile from here. Then all the parameters for this battery, we can change from this workspace. So all the variable value we can change. So let's say I'm just opening this A21. So here we can just click on it and we can change the value. So it will reflect it on this. It will be reflected on this battery. So thank you, everyone. If you came across with any type of doubts, please feel free to ask me. Thank you.